All right, so today we're doing proofs involving congruent triangles. We're going to add something to our notes. We already know about side, angle, side, side, angle, side, 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 angle, angle. Today we're going to add HL. HL. Actually, no, before we do that, side, side, angle does not exist. Angle, angle, angle doesn't exist, and side, side, side doesn't exist. I'm going to show you a video on why side, side, angle doesn't exist. Give me just a moment. Okay. This kind of little animation shows what's going on here. That with up here, angle, side, side, angle, side, side, there are actually two different triangles that could be formed up with a congruent angle and two congruent sides. And that's because this one leg right here could sweep out and form a different triangle. So that's why angle, side, side doesn't exist. So what could happen right here is this guy right here, this angle, or this leg BC, it could either be here in this position or over here in this position, and it shows us actually two different triangles, even though angle, side, side. So that's why angle, side, side doesn't exist. And I think this figure demonstrates why angle, angle, angle doesn't exist, because what's really happening is you're just zooming in and out on it. And so although the triangles are similar, they are not congruent. So if I look at this guy right here, this angle right here, well, that is congruent to that angle. They're both greater than 90. Here's a little acute angle, and that's congruent to this angle. And here's another acute angle. So even though I have angle, 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 it's quite obvious that those two triangles are not identical in shape and size, meaning they are not congruent. Let's get back into those notes, or let's start the notes. Start with your name, and our title today is Proofs Involving Congruent Triangles. Get out your notebook. Proofs involving congruent triangles. Start with your name. Proofs involving congruent triangles, and we are going to list out what we know so far. We have SAS, SSS, ASA, SAA. Over here, we're going to do one of those big red, you can't have these. Boy, my red and orange look the same. So angle, 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 and side, side, angle do not exist. And I just showed you why they don't exist. And what we're going to add today is a new one called HL. New and exciting. HL. What do you think HL could stand for? Side, angle, side, 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 side. HL. HL. It's not angle, and it doesn't mean side. It stands for hypotenuse leg. HL equals hypotenuse leg. And what it means, and there are the two triangles, that if I have two right triangles, and if the hypotenuse of one triangle matches the hypotenuse of the other, and the leg of one matches the leg of the other, then they are congruent. So HL stands for hypotenuse leg. And this only works, oh, excuse me, you can't see what I'm writing. Hypotenuse leg. This only works for right triangles. which is why it uses the word hypotenuse and leg, because the hypotenuse goes with a right triangle. You can't have a right triangle unless, well, you can't have a hypotenuse if it's not a right triangle. So HL works like this. If I have a right triangle, okay, they're both right triangles. Ready? And what it's saying is if I have a hypotenuse that's congruent to a hypotenuse and a leg that's congruent to a leg, then the two triangles are congruent. So what it really is the one, ready? Side, side angle, side, side angle, side, side angle. It's really like side, side, right angle, side, side, right angle. As long as this angle is fixed, it works. So it's kind of side, side angle, except the angle has to be a right angle. So it's kind of so I guess we could think of it as side, side, 90. Side, side, 90, hypotenuse leg is what we call it though. And now that we have that one, we can do some proofs together. And I realize proofs are difficult. And it's going to take us time. And I've got this super duper handy dandy sheet that I can use to try to figure out what's going on with this. And slowly, our goal is to be able to do an entire proof. So let's start with this. All right. Segment AB is congruent to BD. AB is congruent to BD. AB is congruent to BD. How do I know that? It's given to me. Beautiful. BC is congruent to BC. This guy is congruent to itself. How do I know that? Something's congruent to itself. That is, ready? It is reflexive. And now, this is actually missing something. We should have brought in at some point that BC is, let's see, BC is perpendicular. I gotta bring these right angles. I never brought in the right angles here. That's a given. So I would have to bring in BC is perpendicular to AD. So that should have been brought into the proof, but I didn't bring it in. Okay, but let's just look at the picture. What do we have now? We have side, we have a hypotenuse, a leg, so they're congruent by HL. And yes, this proof is incomplete, I see it now, but ABC is congruent to DBC, why? Hypotenuse, leg. Let's see if this one's any better. BC is congruent to EF. BC is congruent to EF. How do I know that? BC is congruent to EF. That was given to me. Angle B is congruent to angle E. Angle B is congruent to angle E. Angle B is congruent to angle E. How do I know that? That's given to me. Angle C is congruent to angle F. Angle C is congruent to angle F. How do I know that? It was given to me. The two triangles are congruent. How do I know that? ABC is congruent to DEF. ABC, DEF. How do I know that? Angle, side, angle. I just completed the proof. Right. Triangle, let's see. Segment AB is congruent to ED. Segment AB, this guy right here, is congruent to this guy right here. You can see over here how I use little arrows to show parallel lines. How do I know that? That was given to me. Segment AC is congruent to EC. So this was the given. I used that AC, EC, AC, EC. This guy is congruent to this guy. How do I know? That was given to me. Angle A is congruent to angle E. Well, that's because those are alternate interior angles. Remember, when I have two parallel lines cut by a transversal, alternate interior angles are congruent. Okay, vertical angles are congruent, right? Well, I know that this right here is congruent to that. How do I know? Vertical angles. ACB is congruent to DCE. How do I know that? Vertical angles. And now we're ready to finish it off our proof. How do I know the two triangles are congruent? Angle, side angle. ABC is congruent to EDC, EDC. By angle, side angle. Gonna do another one. AB is congruent to DE. AB is congruent to DE. How do I know that? Given. AC, DF, AC, DF, AC, DF. How do I know that? Given. Sorry, I was marking up the last one also. Angle A is congruent to angle D. How do I know that? Given. What do I have? Side angle, side, side angle, side, side angle, side. So triangle, let's start at BAC, back, I like that, is congruent to EDF. How do I know? By side angle, side. All right, AB is congruent to CD. AB is congruent to CD. AB is congruent to CD. How do I know that? Given. AD is congruent to CB. AD is congruent to C. Excuse me. AD is congruent to CB. AD, this guy is congruent to this guy. How do I know? Given. Use the reflexive property. Oh, well, this guy is congruent to itself. BD is congruent to BD. How do I know? Reflexive property. How do I know the two triangles are congruent? Side, side, side. Side, side, side. All right, our last one. AE bisects BD. You know what? This should be AE. AE bisects BD. AE bisects BD. Now I know what this, that's what this does right here. Like, you know, I'm going out of order. Okay, so that's a given. So this was a given. Angle B is congruent to angle D. B is congruent to D. That was given. BC is congruent to DC. BC is congruent to GC. Okay, how do I know that? That's the definition of a bisector, that it creates two congruent pieces, and I have that right here. Definition of a segment bisector cuts a segment into two congruent segments. Okay, we're going to bring in some vertical angles here. So I have ACB is congruent to angle DCE. How do I know? Vertical angles. And now the two triangles are congruent. How do I know? Angle, side angle. Right? Angle, side angle. Triangle ABC, ABC, EDC. EDC, good. But I need to fix number 2, don't I? On those notes. And that's it. I realize, man, this is difficult stuff. It's tough for your brain. That's why we're just going to go slowly through it, and we're going to practice this in class. Thank you for watching, and have a good day.